This is Mr. Gordon here with a quick introduction to linear factorisation. Okay, what are we looking at here? We're looking at multiplication, and we're multiplying x plus 1 by 2. Let's write that algebraically as 2 lots of x plus 1. And what's the product? We get 2x plus 2. So that's equal to 2x plus 2. So we just went one way. We went this way round. And we started with brackets and we expanded those brackets. But what if we wanted to go the other way? So what if we started with this expanded version and wanted to get to this, this version with brackets? Well, this is the factorized version. So we need to do factorization or factorizing to get to here. So let's just have a think about factors of numbers a bit. So here we have 12 ones. So we're trying to find out what numbers multiply to give us 12. And we're basically trying to put it into a grid. So, some number times some other number is going to give us 12. So various different ways we can arrange these. And here they are. So we've got 1 times 12. We've got 2 times 6. We've got 3 times 4. And then these are kind of duplicates of those, just the other way around. So instead of 1 times 12, we've now got 12 times 1. 2 times 6 becomes 6 times 2. 3 by 4 becomes 4 by 3. So these are the different ways, these are the different factors of 12. So the factors of 12 are 1, 12, 2, 3, 4, and 6. So this is also a number, but we have a variable, an unknown, which is x. In this case, the number we have here is 1, 2, 3, 4x plus 1, 2, 3, 4, 5, 6, 7, 8. So we're trying to find ways to factorize this. So again, we're looking at what number multiplied by what number gives us 4x plus 8. So I'm going to try and find different ways of arranging these to make a grid. So I need to make sure it's a perfect grid. Those four can go together like that, can't they? That's okay. And if they're going to go there, then I can't put the 1 there because we don't actually know how long this x is because it's variable. We don't know, so we don't know how many could go along that length. So we're going to have to put them here because these ones are the same height as that x. Let's just keep placing them. So we've got 4 of those there, and there's another 4 over here. So I'm just going to remove those 4 and put them up at the top there. And that's what we get. So we find that the height of this is 1, 2. These are the 1 block height. So we could have a 1 block there and a 1 block there. So in total, we've got 2. And across the top here, we've got, well, that's the same as that x and the same width as that x there, which is a total of 2x. And we've got 1, 2, 3, 4 across there, 4 1 blocks, 4 of these. So that's 4. So we've just factorized 4x plus 8 into 2 lots of 2x plus 4, of 2x plus 4. And we can see if we did it the other way around, if we expanded, 2x times 2 gives us 4x, and 2 times 4 gives us 8. But when we're factorizing, what we're looking for here, if we're imagining it like this grid, we're looking for the grid that's closest possible to a square. So this is quite kind of oblong at the moment. We want to make it a little bit more square-like. So let's see if we can find another way to arrange these blocks now. So if we put them down like this instead, and maybe we can take all of these and move them over there. Well, it's not a rectangle yet. We've got to do something about this space. So let's take those 4 and move them down there. And that's kind of worked, right? So let's find out what the products are of this, what the factors are of this product. So we've got the same product here. The total of the product is 4x plus 8, but we factorized it in a different way now. So we've got 4 of these 1 blocks that's how high it is, which is just the number 4. And in terms of the width, we've got an x there, and we've got 2 1 blocks. So that's x plus 2 wide. So we've multiplied together 4 by x plus 2. So we've multiplied 4 by x plus 2. Okay, when we're factorising, this is what we're looking for. We're looking to take the highest possible factor out. We're trying to make this into as close to a square as possible. So the factorised version of 4x plus 8 is 4 lots of x plus 2. Now, if we factorised it this way, we should be able to see that we can keep factorising it further. So we're basically looking for numbers which are factors of both of these numbers. So what's the highest common factor of 4 and 8? It's 4. So we can take 4 outside, and it's 2 lots of 4 make 8. Okay, a little bit harder now. We've got some x squareds as well. We've got 1, 2, 3, 4x squared, and 1, 2, 3, 4, 5, 6x. And again, we're looking to make it into a rectangle as square-like as possible. So, we could put all 4 of these x squareds in one long line, but if I want to make it as square as possible, I'm going to put it this way around instead, if I want to fully factorise it. And let's put these at the bottom here. There we go. So I think, yeah, that looks pretty much like a rectangle now. And let's have a look. It's we could put an x blocks in there. In terms of the height, that's how high these x squareds are. And that's a 1 block there, and another one, another one. So in total here, we've got 2x plus 3. And in terms of the width, we've got 1x, 2x, so it's 2x wide. So to factorise 4x squared plus 6x, it is 2x times 2x plus 3. Okay, 2x times 2x plus 3 gives us the product 4x squared plus 6x. So that's how we factorise.